Hi, everyone. I'm Vanessa Sockett. I am a computer scientist at Lawrence Livermore National Lab. And today I want to talk about collaboration and working together. And I want to present this in two ways. First, with software that I'm working on called Singularity, Registry, HPC, collaborative container modules. But then I want to get a little meta and kind of think about how we work together. So I want to propose to you today that there is this high-level formula for collaboration that we all kind of know about and we do without thinking about it. And it really starts with identifying an actual need or a problem that crosses communities that will inspire collaboration. So with that in mind, let me present you with a problem. As you know, when we use high-performance computing systems, we have this need to install software. And as containers have become more popular, that need has sort of transitioned to wanting to provide containers to users. And so what you're looking at here is documentation from UVA Research Computing. And you see that they had this problem. They wanted to provide containers to their users. They tried Singularity Library. It didn't have enough space. So they said, OK, let's make a Docker Hub organization. Here is how you pull the container, best practices, etc. Of course, using these traditional registries like Docker Hub and Quake.io, it's kind of problematic because they weren't really designed with the HPC use case in mind. You know, imagine every user is pulling their own set of containers. That's a ton of redundancy. Users are probably not thinking about best practices, meaning they're probably pulling a latest tag, which is a moving target. They're also probably pulling the same container at the same time to like 10,000 nodes, which is neither good for the cluster or the registry. And so while it's not impossible to be reproducible, it's kind of really hard. It's very challenging. So ideally, what if we had a registry that was sort of native to HPC? So an admin could install and provide containers for their users, or users could also roll their own, maybe just for their lab or something like that. And what if it was done in a way to encourage reproducibility and make it easy? So back to our formula for collaboration. So the next step is we have to find an idea that fits into the way that people currently think and their current practices, because asking someone to like learn something new or do something totally new, it's just not really going to happen. So I thought about this and it's like, you know, the way there's sort of this bread and butter way that we provide software users on HPC clusters, and that is with environment modules. So could we provide containers as modules? And in fact, you're probably saying, Vanessa, that is not a new idea, and you are correct. So I did a little digging, and here's an example of software called Community Collections, which had in mind to be provided to an admin. An admin would write a bunch of recipes and then build them and then install them for use by the user. When I looked a little closer, though, so here we're looking at the configuration file, I found some things that I thought were problematic. So while it might be great for an admin to be able to maintain one file, this would make it very challenging for sharing your recipes because everyone's configuration file is going to be like a special snowflake. Also, if you look here, you'll notice that it's sort of limited in how you can define interactions with containers and even the calls to them. And also for versions, it's a range of versions. You can't say like, I want this exact tag and this exact digest. So overall, I thought it was not really easy to collaborate on, not totally modular enough, and not enough granularity in being able to sort of define these interactions. So with these things in mind, I could then start to put together my plan for my idea that would fit into current practices that would solve this problem. My first goal was reproducibility. I wanted it to be possible to find exact tags and digests. The next thing is I wanted it to be easy to use. So maybe clone a repository, pip install, and then be done. And then to some degree, I wanted a little bit of abstraction. So interactions with containers can be complicated, like container software, do this thing, bind all these things, all these other options. And I wanted the user interacting with the module to just feel like they're interacting with an actual binary. And finally, I wanted automation. So once a container recipe is added to this registry, I don't want to have to manually update anything. I want this just to happen automatically. So I built a thing, and let's talk about how it works. Well, installation is easy. You git clone, you cd, you pip install, and then this executable shpc is available for you. Now you probably next want to install some containers. So you could use the command line tool to look at what's available in the registry, but there's also a nice web interface where you can browse and search and see all the containers and all the aliases that are exposed. So for example, there's over 200 of these, and they range everything from biocontainers to the brain imaging data structure, Jupyter and NVIDIA, pretty much all the sort of hardcore use cases for HPC. Okay, Now you choose one, let's install it. So here I am installing Klingo. The container is pulled using Singularity. Since I'm a user, I would then need to tell lmod to use this modules folder. I then load my module, and you'll notice here when I'm typing, I'm pressing tab because there's automated completion. Once I do that, that executable, well, the executable, it's not really an executable, it's a container command, is available on my path, and I can interact with Klingo. So there I am saying that there's a dinosaur named Vanessa. Huzzah! These commands can get pretty complicated. So let's say you're a user and you want to run a notebook. You would normally have to remember this really hugely complicated command, everything from interacting with Jupyter, knowing where things are in the container, doing binds, specifying a port. And what SHPC does for you is it makes this so easy to do. You just run notebook, done. Okay, great. So we've kind of shown how it looks like, but what does this registry actually look like? Well, it's a file system registry. So if you look in the root of the repository, you'll see this registry folder. Here you'll recognize, Docker, unique resource identifiers, namespaces. So for example, if we look in biocontainers, we see biocontainers Abyss. That would coincide with the biocontainers Abyss container on Docker Hub. Within each of these folders, we have a container YAML file, and that's going to specify everything about this entry. So for example, here we're looking at the biocontainer SAM tools. Here's a unique resource identifier on Docker Hub. There was a latest tag defined, which is a tag and a digest. You can also define one or more tags so that they're available even if it's not the latest. The filter is important because that tells the bot that's going to update this recipe, only look at the tags that start with V because those are released versions. And then finally, there's a set of aliases. So this is a tiny one. There's only SAM tools in the container, but this list can actually get very large if the container serves multiple things. I mentioned automation. We have a bot named Binok, which was created by the very talented Alec, who's doing an internship at the lab this summer. And Binok basically opens a pull request every day to update versions of containers. So here's an example of updating Beast 2. Binok has discovered there's a version 2.6.4 that is now latest, and he's updating that accordingly. Also, we have automated testing of containers. So if you apply the container recipe label to NEPR, it'll automatically test actually, building the container, loading it as a module. So back to this formula for collaboration. Okay, we started with a need. We then moved on to say, okay, how can we meet this need with an idea that kind of fits into current practices, so environment modules. And guess what, folks? Now it gets hard because now we have to figure out how to make a contributor-friendly learning environment. And so the obvious answer to this as well, you need really pretty documentation with a getting started guide and how to install and tutorials, and maybe you have a little branding and it's colorful or a cute robot or something like that. Once you kind of do these things, if you're like me, you check off all the boxes and then you say, okay, well, what do I do now? I mean, is this like a field of dreams kind of thing? Like if I build it, they will come. And the problem is that when you really kind of zoom out, there are projects, to be fair, that we collaborate on, and they're kind of set up and intentional. But for the most part, for these small projects, we kind of work in these small silos. And there's this question that I think we need to ask more. How do we work together? Because we have so many things in common. We are, for the most part, using HPC to some extent. We're using common kind of open source software that helps us to do things on HPC, like Singularity containers, which we talked about here. And we also really get excited about open source development. And I probably don't need to convince you of this, but there's many benefits to collaboration, everything from better ideas and approaches to using best practices, and we can also learn and grow from one another. And as you know, there's also a lot of reasons that we shouldn't collaborate. So it's very expensive in terms of time and effort, setting up those Zoom meetings and the Google documents. And it's also because there could be concerns about intellectual property. Maybe there's a security clearance required for a national lab, so it's just not possible. And it's also just expensive. So if you wind up needing to actually pay people for their time, you have to get funding, and well, maybe you can't afford it. Okay, so at this point, I realized I wanted to do something. I realized that I saw this opportunity, but the problem was at my institution, I didn't have a good sense. I didn't have a good sense of a baseline of how we were doing. And so I started by saying, okay, maybe I can figure that out by looking at data. So I started at the LLNL software portal, And this has like about the 735-ish packages, different open source software. And I won't show you all the plots because I don't have a lot of time for this talk. But overall, what I saw is that we're doing really well on a few key projects, maybe just 3. They're really excelling in attracting external contributors. But what was interesting is that the projects at my institution that had the most people working on them internally, they're on GitHub, they're public. Those were not the projects that had the most people working on them externally. So there's some kind of mismatch between like what the lab thinks is important and what outside people think are important. And maybe it's also because these projects aren't contributor friendly. And then I saw this long tail. So I will show you a quick graph to explain what I mean. So I was looking at contributors broken down by internal versus external at the lab. These first couple of bars are actually just a couple of projects, so SPAC, MFEM, and ZFS. So it's less impressive than you think. But here's the problem, okay? This is only 1/6 of this graph. This thing just goes out into like infinity, not infinity, but like way off of the browser. And there's this long tail of projects that people are working on at the lab, but I personally don't know about. And I bet you most people out there in the wild of the open source community don't know about them either. So again, back to this question. Now I see that I think we can do better. And the question comes down to how. So my plan of action, and I'll finish this up quickly. I want to create something called Contributor CI, the set of tools and procedures that you can use to assess contributions. And I think I want to start with a baseline. So I'm going to create a GitHub action that's going to collect metrics to measure these contributions. And it's going to automated do it for you over time so that you can see how a project changes or many projects change. And then I think the next step is to do this thing I'm calling a contributor friendliness assessment. And this is a little bit manual because it means looking at a repository and seeing how contributor friendly it is. And then finally, when we have that information, I think we can actually take proactive action, keep the timestamp of when we did it, and then see if anything that we've done has influenced the metrics that we're collecting. For the contributor friendliness assessment, just to give you a sense of what I want to, the kinds of questions we want to ask, it's about use cases and what's in the documentation. And then for the action, well, this is kind of also straightforward. Identify things we can do them, and then see if they had any effect. So I want to finish up today and give you a call to action, because I think this is something that we should care about. If we're all working on similar things and we have similar goals, why is it that it's not easier to work together? It is so hard to work together across these very siloed RSE communities. But maybe, I independently can't just like fix this problem, but I can reach out to you and say, can you look at your institution and really do an assessment of, what is being developed, who's developing it, what kind of developers are there? Are they internal? Are they external to your institution? How contributor friendly are your projects? And then once you have that information, to take action to improve the scores. And I don't have tools or anything developed yet, but I will invite you to kind of join me into thinking about this and working on this. So that's all I got. I'm out of time. Thank you, everyone. Are there any questions?